Hi there, you. Today we're going to talk about statics. A system of concurrent forces is shown below. Find A, the resultant force magnitude, and B, the angle made by the resultant with the x-axis. The first thing we're going to do here, we're going to write each force as a vector. And to do that, I'm going to have to go back to math polar coordinates and just remind you that in order to write the x component, it is equal to r cosine theta, y component r sine theta, and then the angle theta equals to arctangent of y over x. So in statics, we're only given the magnitude of the resultant force and then the angle theta, which is again is sum of y forces over sum of x forces. So let's go and start. We're going to start with this 200 Newton force. We have to place at least imaginary detail at 0. So this is x and y axis. Let's imagine x, this is y. And we have to acknowledge the force is in the third quadrant. The angle is measured from x-axis all the way to the force. In this case, we have 150 angle here, plus 90 degrees. The angle is going to be equal to 240. So we're going to start by saying F1 is made out of 200 Newton force and 240 degree angle is going to be equal. So we have x cosine theta. In our case, x is, or r cosine theta. It was, in our case, the r is the force is 200 multiplied by cosine of 240. This is the I component plus 200 sine of 240, and this is J equals, I'm going to come back here, equals. So take your calculators. I'm going to say 240 cosine 200 multiplied. So I have minus 100 I, and then we have 240 sine 200 multiplied minus 173.2 J. So this is the vector of the force number 1. Next, force number 2, let's go to the 500 Newton force. We're given the slope and the force, say F2 equals 2. And if you don't know how to write the components of this force when you're given the slope like that, this is a good way for me to explain it for you. So when you're given the slope like that, you have a right triangle with two catetes as 1 and 2, and then we have to calculate the hypotenusa. Hypotenusa is going to be equal to 1 squared, 2 squared, plus square root of that. So I'm going to write the hypotenusa as square root of 5. And so the x component, it's going to be equal to 2 over square root of 5 multiplied by 500. And this is I plus 1 over square root of 5 multiplied by 500. And this is J. And in this case, we have to acknowledge the fact that the x component of this force is going to be directed towards the positive side, and the y component, or the j component, is going to be directed downwards, which is towards the negative side. So here, the j component is going to be minus equals. So I have 2 square root of 5 divided 500 multiplied, get 447.2, 447.2 I minus, see, we have 1 square root of 5 divided 500 multiplied minus 223.61. That's just 6J. And the last force, F3, equals to, let's talk about F3. So remember, we have to add the coordinate system here. This is the x-axis, just imaginary like that. And then this is going to be the y-axis. And this is our angle is 60 degrees. That means that this angle is also 60 degrees. So the angle we're going to use is the angle made with the x-axis and the force. So this angle right here, which is 180 minus 60, which means the angle is 120 degrees. So the force is going to be made by the 100 newtons and 120 degrees angle. And again, we're going to say it is 100 multiplied by cosine of 120. And this is I plus 100 multiplied by sine of 120. This is the J. And let's calculate that. I have 120 cosine 100 multiplied. So I get minus 50 I 120 sine 100 multiplied. I get 86.6 plus 86.6 J. So this is the three forces in vector form. And another note that I will make here, let's say you start this problem and you don't know about the polar coordinates, or you don't know how to write this in vector form. What I want you to remember is that you can do this without knowing this formula here. You can just, if you were to say this is the x-axis, this is the y-axis, and you have your force in the third quadrant, we know that this is 150. We can find out that this angle here is going to be equal to 90 to 150 minus 90 degrees. So the angle is going to be equal to 60 degrees. And then you can just use this 60 degrees angle to calculate the x component and y component of this force. So you have x component and you have the y component. And just recognize that they are both pointing towards the negative side. So you're going to have negative I force and negative J force. And from this, you are going to get the same results as I got here. And the same you can do for, in this case, if you were to draw your right triangle here, this is a 60-degree angle, and then this is 30-degree angle, and you can calculate the x and y component and build your vector this way. Just recognize the fact that in this case, the x component of this force is going towards the negative side, and the y component goes upwards towards the positive side, which means you're going to have a negative x, which we got here, and then a positive y. Anyway, this is just a small note. Now we have to calculate the resultant force. The resultant force is going to be equal to sum of Fi, and I will have minus 100 I minus 173.2 J plus 447.2 I minus 223.6 J. And finally, you have minus 50 I plus 86.6 J equals, let's use the calculator. I'm going to first add everything, the I components. So I have 100 minus, I have 50 minus, add them up. And then I have 447.2 plus. So the I component, I get 297.2 I. Then let's calculate the J components. I have 173.2 minus 223.6. The minus as well. Add them up. And I also have 86.6. And this is a positive term. The result is minus 310.2, and this is the J. So this is the resultant vector. And in order to calculate for the magnitude also given in the FE handbook is the square root of each component squared. So I will have square root of 297.2 squared. Wait a second, goes more. Plus minus 310.2 squared equals, let's do this, squared, then 297.2. And the resultant vector is 429.6 newtons, which is approximately 430 newtons. I'm looking at the options here, and I can see that option C is giving me a resultant of 430. And I believe when you are on the exam, you can just stop here because you want to make sure you save time. But we're going to keep moving forward, and we're going to calculate for the angle theta as well. And I have no space, so I'm going to have to delete something here. Let's see. No, I'm going to delete this. Okay, so angle theta per formula in the FE handbook is arctangent of sum of Fy forces over sum of Fx forces. So I have the Fy as 310/2. So I'm going to do 310/2, and this is minus, over Fy is 297.2 equals, let's do this calculation. I have 310.2 minus, it's a negative, over 297.2 divided, and arctangent gives me an angle of minus 46.22 degrees. And look at that. Option C, it is the correct answer. Great. Let's move on. A frame ABCDE is supported by a hinge at A and roller support at D as shown. If the 30 kilonewton force at C and the distributed load over DE is to be replaced by a vertical acting upward force of 12 kilonewtons at C while maintaining the same reaction at support D, what is the additional moment that must be applied at C? Okay, this might have been too much information at once, so let's take this once again. So we're told if the 30 kilonewton force, so we have this 30 kilonewton force at C, and the distributed load over DE, and this load is to be replaced by a vertical acting upward force of 12 kilonewton. So we're going to remove these two forces, and I'm going to replace them with a vertical force at C acting upwards of 12 kilonewtons. while maintaining the same reaction. So nothing else changes. We're just going to remove these two and then add the 12 kilonewton force. And the question is, what additional moment do we have to add at this point C in order to keep these two systems equivalent? So in order to proceed with this, what I'm going to do is first, we're going to acknowledge what are we removing. So we're removing this 30 kilonewton force and this distributed load, and nothing else changes. So let's see, based on point A, if we are going to take the moment about point A before we remove the forces, and then we're going to calculate the moment about A after we remove the forces with the new force going upwards. And after that, we're going to discuss and see what else we can do. So the moment about A with the forces that we're going to remove, it's going to be equal to 30 kilonewtons multiplied by the arm, which is 1.7 meters, plus we have 4 multiplied by 0.8 and multiplied by 1.6, 0.6 plus, and 0.4 plus. So I have multiplied by 2.6. And this, let's see, what is the moment here? 2.6, 0.8 multiplied, 4 multiplied, and then 30, 1.7 multiplied plus. So I get a moment of 59.32 kilonewtons meters. So this is the moment we are removing. Now we are adding the 12 kilonewton force. Let's calculate the 12 kilonewton force. Let's calculate the moment about point A with the 12 kilonewton force. So we're going to get, this is counterclockwise, it's going to be minus 12 multiplied by 1.6. And I get a moment of minus 19.2 kilonewton meters. So now let me also draw something for you. So imagine I'm going to draw this system and I have the moment about point A. This is A. And I'm going to say, so in the first system, we removed a moment, let's do clockwise moment of 59.32. Now in the second system, where we removed these two forces and we added the 12 kilonewton force going upward, so this is system number 1, this is system number 2, we got a moment going counterclockwise of 19.2. So now the question is, how do we make these two systems equivalent? Well, think about it. In order to make these two systems equivalent, we have to end up in the second system with the moment going downwards of 59.32 kilonewtons meters, right? So we have to add a moment of 59 plus we also have to add a moment of 19.2, which is gonna get rid of this counterclockwise moment. So this with this, it's gonna go away and I'm gonna be left with 59.32 moment. Does that make sense? I hope it does. So the final moment that I have to add in order to end up with a 59.32 moment, as we initially had before we removed these two forces, it's going to be equal to 19.2 plus 59.32 equals, and I get a 78.52 kilonewtons meters. And this is clockwise. And that's it. So the correct answer is going to be C, 78.52 moment clockwise. Great, let's move on. A beam is supported by a hinged support at the left and by an inclined roller on the right, as shown below. What is the reaction at the hinged support on the left? So we're asked of the reaction at this support, and we're not told if it's horizontal or vertical. So the reaction at A that we're going to have to calculate is going to be equal to the vertical reaction at A plus horizontal reaction at A squared equals. So this is what we're going to calculate. We need to know the vertical and horizontal. And then we're going to come up with the reaction at the support A. This beam has a uniformly distributed load. It has a point load, which makes an angle with the beam, and we have a roller that is inclined. So let's see how we're going to proceed here. Let's start by drawing our reactions. I'm going to write, this is VA, and then this is going to be equal to HA. And then here, I'm going to have the RB, reaction at B, which is, let's see, this is 4 and this is 3. Let me make this a bit more clear. So I'll have, this is the reaction at the B. I'm going to call this RB. And based on this triangle given here, the slope, if I am to redraw this, this is going to be 3 and this is going to be 4. All I do is just rotate this triangle and I'm getting this slope, which means now if I want to rewrite these forces, I will have an RB horizontal, or I'll have HB and VB. HB, let me write this down. So HB is going to be equal to, again, 3, 4. That means that this hypotenusa is 5. We're going to have 3/5 multiplied by RB, and VB is equal to 4/5 multiplied by RB. Since we're here, let's also rewrite these forces. We're going to have a vertical component of this force and a horizontal component here. And this is going to be equal, let's see, what is the hypotenusa? This is 12. So hypotenusa, I'm going to have 12 squared. And we have 5 squared plus square root of that. This is 13. So the hypotenusa is 13. So in this case, if I want to write the force, the x component, Fx equals 2, and it's going to be equal to 78. Hold on, let's start with writing the 5/13 multiplied by 78 equals, and then Fy, the y component of this force, it's going to be equal to 12/13 multiplied by 78. And I'm going to go ahead and calculate that. So I have 5/13 divided 78 multiplied. Fx component equals to 30. And Fy component 12/13 divided 78 multiplied. And y component equals to 72. Perfect. Another thing I want to do is I want to calculate the resultant force here, and I'm going to make a correction. This is not 4 kilonewtons, this is 40 kilonewtons. So let me correct this here. So this resultant force, 40 kilonewtons per meters, it's going to be equal to 40 multiplied by 1.3, and this gives a resultant force of 52 kilonewtons. Perfect. So now we have everything laid out. Let's calculate for reactions. We're going to start by, let's do sum of moments in point A equals to 0. So this is actually the VB, the vertical, and this is the horizontal, HB. And just to kind of make this easy for you to understand, VB is actually here, and HB is translated over here. HB and VB. So I'm gonna, I guess, delete this. This is the RB resultant. Okay, HB, which it's not going to be the case. We're going to work with VB. So moment in point A, moment about point A equals to VB multiplied by, and we have 2.6, 3.6, 4 point. Let me write the length of this entire beam. Equals to 5.1. Okay. So VB multiplied by 5.1 minus FY, which is 72, multiplied by 2.6, 3.6, 3.6, and then minus this uniform distributed load. The resultant is 52 multiplied by, we get 1.3 divided by 2, 1 plus, and I get 1.65. So the arm of this resultant of uniform load is 1.65. And these are all the loads I have. So from here, I can calculate for VB equals the results VB is equal to, and I'm going to write 5.1 here. And then here at the top, I'll have 72 multiplied by 3.6 plus 52 multiplied by 1.65. And this gives me a VB, let's see, 1.65, 52 multiplied, and then 3.6, 72 multiplied, add this up, 5.1 divided. So VB is equal to 67.65, and these are kilonewtons. So I got this reaction as 67.65. And now we can calculate for VA. If we do sum of forces in the y direction, we can calculate for VA. Sum of forces in the y direction equals to 0. And from here, let's see, we have VA, positive going upwards, minus 52, minus FY, which is 72, and plus VB, which we just have calculated, 67.65, equals to 0. From this equation, VA is equal to 52 plus 72 minus 67.65 equals, get 56.35. 56.35 kilonewtons. So VA, and this is VA. Let me to this. And now we know VA, we have to calculate for HA. And HA is going to be calculated from the fact that we know VB. VB is 67.65. And from here, we can calculate for RB. So 67.65 equals to 4 multiplied RB divided by 5. And from here, RB is equal to 67.65, 5 multiplied, 4 divided. So RB equals to 84.56 kilonewtons. So this is this reaction, inclined reaction over here. Just point downwards like this. And now that we know RB, we can calculate HB. So HB is 3/5 multiplied by 84.56 equals 3 multiplied, 5 divided. So HB is 50.74 kilonewtons. So this is HB. Now we have HB, and we can calculate for HA. If we do sum of forces in the X direction equals to 0. From here, I'm going to have HA minus this horizontal force, Fx, which is 30, minus 30, and minus HB, and HB is 50.74 equals to 0. From this equation, I can solve for HA, which is equal to 30 plus 50.74 equals 80.74. And this is HA. So now with these two forces known, we can calculate for the reaction at the left support, and it's going to be equal to 56. VA is 56.35 squared plus 80.74 squared. And let's see how much is this. I get 98.46 kilonewtons. And the closest answer is D. RA equals to 100 kilonewtons. Great. Now we can move forward. A frame ABCDE is supported by a hinge at A and roller support at D as shown. The frame is subject to the following loads: a clockwise couple 20 kilonewtons meters on joint B, a 30 kilonewton force at C, and a uniformly distributed load 4 kilonewtons per meter over DE. What is the vertical reaction at D? So you might recognize this is the same frame we've used in our equivalent force systems. And in this case, we're just asked to calculate what is the reaction at the support D. So I'll call it VD. You have to calculate. So this is pretty easy to do. All we have to do is sum of moments at point A equals to 0. And this is going to be equal to VD multiplied by, and the arm is 2.2 meters. So this is counterclockwise. Have minus, let's take the moment, 20 kilonewton meters. And then we also have clockwise minus 30. I'm taking this force over here, 30 kilonewtons multiplied by the arm, which is 1.7. And then this uniformly distributed load is also gonna create a clockwise moment. So minus 4 multiplied by 0.8 multiplied by the arm, which is 1.6 plus 0.6 plus 0.4. 2.6 equals to 0. From here, we can calculate VD equals to, let's draw this line, 2.2, and we have 20 plus 30 multiplied by 1.7 plus 4 multiplied by 0.8 and multiplied by 2.6. So we have 20, 30, 1.7 multiplied plus 4, 0.8 multiplied, 2.6 multiplied plus 2.2 divided. So I get a reaction of 36.05 kilonewtons. And that was very simple. The correct answer is C. Okay, let's move forward. Now we are at trusses and method of joints. We're going to talk about method of joints. For the plain truss shown below, calculate the force in member EF. So member EF is, right, this member. So obviously the easiest thing to do is to use method of joints. First thing, when we have to use method of joints, we have to calculate for reactions. So I'm going to write here reactions. I'm going to add here VA. This is VE. This is, let's point it the other way because we have this force pulling on the right. The AJ is going to pull on the left, HA. So first, I'm going to do sum of forces in the X direction equals 0. From here, I have minus HA equals to, let's do HA just to make it simple, equals to 5 kips. Great. Next, we're going to do sum of moments in point A equals to 0. From here, we have VE multiplied by 20 minus 10 kips multiplied by 10 and minus 5 kips multiplied by 8 equals to 0. From here, VE is equal to 100 plus 40 equals to, I have 140 over 20, and this equals to 7 kilonewtons. So VE is equal to 7, AJ equals to 5, and now VA. For VA, I'm going to do sum of forces in the Y direction equals to 0. From here, I get VA plus VE, which is 7, and minus 10 kips force equals to 0. From here, VA is equal to 10 minus 7 equals to 3 kilonewtons. So VA equals to 3. And actually, if you want to be even smarter, you just need to realize that we didn't need the reactions at point A. We didn't need to calculate them. So the only thing we could have done is the moment about point A, and this would have given us the VE. And the reason is, since we have to calculate the force in member EF, we're going to start at this point and calculate for the force, and we don't need to know all these reactions. But that's all right. Now let's start by calculating the forces in node E. So here I'll have force EF, and then I have this member, and this is FED, and then I have the reaction pulling going upward of 7 kilonewtons. This force FED is going to have an X and Y component, which I'm going to draw here. FEDY, which is going to be equal to, if we are about to calculate the hypotenusa here, I'll have 5 squared, 8 squared, plus, and then square root of that. This hypotenusa is going to be equal to 9.43, which means if we want to calculate the Y component and the X component, starting with the Y component, is going to be equal to 8 over 943 multiplied by FED. And then the X component is going to pull in this direction. I'm going to draw it here. FEDX is going to be equal to 5 over, so this horizontal over 943 multiplied by FED. Perfect. So now, in order to calculate for the force member in this node, we're going to do sum of forces in the X and Y direction. So sum of forces in the X direction equal to 0. We get FEDX equals to FEF. And this is equivalent to 5 over 943 multiplied by FED is equal to FEF. And now we have to go to the sum of forces in the Y direction. Sum of forces in the Y direction equals 0. And I will get 7 going upwards, positive, minus the Y component of force FED. And the Y component is 8 divided by 943 multiplied by FED equals to 0. And from here, we can say that 8 over 943 multiplied by FED equals to 7. And from here, we can calculate for the FED force. See, FED is equal to, see, 943, 7 multiplied, 8 divided. So I get FED as 8.25. And now that we know FED, we can come back here and the FX equation and calculate for FEF. So from here, results 5 over 943 multiplied by FED, which is 825, equals to FEF. And this equals to 825, 5 multiplied, 943 divided. So I get FEF as 4.38 kips. And this is approximately 4.4 kips. So the correct answer is C, 4.4. Not too bad, not too bad. And the final problem for today, we have the same truss, but we have to calculate the force in member CG, which is this over here, vertical member, and we have to use method of sections. Remember, when we use method of sections, we have to remember that we cannot have a cut in more than 3 members. And I had an example previously where the truss was looking somewhere like this. and I had to calculate the force in one of these members. And so in order for you to do a cut here, you have to cut through 4 members. And one of the rules when using method of sections is you cannot cut in through more than 3 members. So an important thing to recognize here is that, let me delete this, is that these 2 members are 0 force members because they don't have any forces and on this node pushing towards it. So they have to be 0 force members. So all you do is just take them away because they're 0 force members. And now you can easily do the cut through your truss and calculate for force in member CG using method of sections. And okay, first step here is also calculating the reactions. We did this in previous problems, so I'm going to just add here VE is equal to 7, I think. And we also have VA, and we have HA. And you can start with either the left side or the right side to calculate the force in member CG. I'm going to use the right side, but you can go ahead for practicing, use the left side because you have to come up with the same results. So just to practice, to verify yourself, use the left side as well. So reactions is the first step. And then I'm going to draw this side of, so this is the 5 kip force. And then I'll have like that. And like that. F, C, G. This is F, C, D. And then we also have this force over here, which is F, G, H. There's also force pulling downwards of 10 kips. This is 5 kips. Okay, now these dimensions are 5 feet and 5 feet. And this is 8 feet. Our goal is to find FCG. Let's see how we can do this. Oh, we also have the reaction, which is 7. It seems this is a pretty easy case we have. If we do sum of forces in the y direction equal to 0, it's going to give us FCG. So let's do that. Results. I'm going to have FCG minus 10 plus 7 equals to 0. From here, FCG is equal to 10 minus 7 and equals to 3 kips. That was a pretty easy case. We got lucky here. 3 kips. The correct option is B. And you know, since this was so easy, let's try and calculate the force in member CG using the left side. So if I want to draw the left side, let's see, I have one line down here, I have one line down here, and then one like this. This is the HA. Let's see what is the reaction. We have HA is 5. So I'm going to correct this here. Let me do HA is pulling towards the left, and HA is 5. And then VA going upward equals to 3. There you go. So if I am to use this left side, I'm going to represent the reactions just like that. And then the easy part is that we don't have any other forces because this 10 kip force and 5 kip force, they're on the right side. Let me correct this. This member here this is going to be FGH, and then pulling downwards, we're going to have FCG, and this force is FCD. If you notice here, the only unknown force on the vertical side is FCG. So this becomes also like each side you choose, it's easy. So F of forces in the y direction equal to 0. This results that FCG equals to this reaction over here. And FCG equals to 3 kips. Okay, that was easy. Both sides were easy. So the correct answer is B. That's it for this week. Next week, we have some more problems in the FE review statics. If you found this video helpful, don't forget to subscribe and give it a like. Keep on practicing the FE problems, and I will see you next week.